Well, what happens when it's not so simple? It's called these indeterminate forms. When you plug in your number and you get 0 over 0. At that time we're going to have to factor and reduce and then take the limit. So let's see, on this problem, if I were to just plug in 1, which is what I would do first, see what happens. I get 1 minus 1 over 1 minus 1, oops, that's called, we don't know what 0 over 0 equals to, so it means go try again. So, let's see, I'm going to factor, so that's the difference of 2 squares. Then I'm going to reduce. And then I'm going to take the limit by plugging in my value for x, and I get 2. Right? If you have a graphing calculator, you can get one off the web. Again, not necessary. You might want to graph that and zoom in really close at 1, and you're going to see a little tiny hole right there. And that's why you get that 0 over 0. Okay, let's look at the second problem. Okay, so again, if I plug in negative 2 everywhere for x, let's see, I would get 6 over, I would get 0 over 0, which I can't do. Go back, try again. So I'm going to factor these trinomials. Going to check my signs. Everything checks out, and those reduce out. So I have the limit as x approaches negative 2 of what I've got left. And now I'm going to plug in negative 2 everywhere I see an x, and I get negative 5 over negative 3, which would be positive 5/3, and that's my limit. Right? This last example, same thing. If I plug in 0, I'm going to get 0 over 0. So I'm going to factor. That top one has a GCF of an x. Those reduce out, and so this is what I have left. Now I'm going to plug in 0 for x. I get 2 times 0 minus 3, which is negative 3. Alright, so first of all, you just want to plug in the number for x, see what happens. If you get a number, an answer, go for it. If you get 0 over 0, think about, could I factor and reduce? Right, the next thing we're going to look at are limits of infinity. Alright, so again we're going to look at a graph. So this asks us to find the limit as x approaches positive infinity. What is that equal to? The limit as x approaches negative infinity. What is that equal to? Okay, well, where is positive infinity? It means as x gets way out here, what does y get close to? Well, you notice this graph is a parabola. It's just going to keep going up and up and up, and we would call that positive infinity. Okay, so negative infinity, that's this way, right? That's where x is going that way. What is y getting closer to? And again, this is going up and up and up, so we would have positive infinity. Now that's okay, or just like before, we could also say the limits does not exist because it's not approaching any finite number. Alright, let's look at number 65. Same thing. The limit as x approaches positive infinity. Alright, so as x is going way out here, what is y doing? Well, this graph is getting smaller and smaller and smaller. In fact, it's getting so small, we would say the limit is 0. In fact, if you plug in some numbers, 1 over x squared, let x be 10, 100, 1,000, you're going to see that that fraction is getting smaller and smaller. Alright, well, what about as x approaches negative infinity? Okay, so that's on this side. As x is getting further and further out, what is this graph doing? Well, this graph is getting smaller and smaller and smaller also approaching 0. And again, if you let x be -10, -1,000, -1,000,000, you're going to see that fraction getting smaller and smaller and smaller. Right? And that's going to become really key in some more examples later on. Okay, now let's look at this graph I've made up. Okay, so we want the limit as x approaches positive infinity and negative infinity. Okay, so x is this way. What is y getting closer to? Well, you can kind of see that this graph is flattening out. Okay, it's getting closer and closer to the value of 2. But on the other side, when we're going this way, is y getting closer and closer to a number? No, it's going up and up and up, so we could say positive infinity, or again, we could say does not exist. Both of those answers would be acceptable. Now, that's different, okay, than, go way up here to number 7. You could not say positive or negative infinity here. The limit does not exist because these two values just didn't meet. Alright, so you want to look at those graphs, positive infinity, negative infinity. You could also do it using a table of values. But right now I just want to say what happens when you just have a function. Okay, and this is to evaluate the limit at infinity or negative infinity of a rational function, which is a fraction. And we want to divide the numerator and the denominator by the highest power of x in the denominator. Right? And we're going to use this idea that when you have 1 over x or 1 over x to a power, as x gets really large, that fraction gets really small. So just think about 1 over 2 is 0.5. 1 over 10 is 0.1. But when you start getting bigger numbers in the denominator, the fraction just keeps getting smaller. Alright, and so we're saying that as x gets really large, this value has a limit of 0. Alright? Okay, so let's look at this problem. The limit as x approaches infinity of 3x plus 2 over x minus 5. So we have a limit of infinity, we have a rational function. You can't just plug in infinity. So what we're going to do is we're going to divide the numerator and the denominator by the highest power of x in the denominator. So that's the highest power is just x. So let's see. This is going to look really weird, but it's very easy. So dividing every term by x, then we're reducing. Eventually you'll really be able to do this in your head, but for right now we need to show our steps, okay, so we know what we're doing. Okay, now notice that now I've got just these fractions left. So we want the limit, so we're going to use this idea. So as x gets really large in the denominator, this value gets closer and closer to 0. So does that fraction. The limit is 0. It gets so close it's negligible. So what we have left is 3 over 1, which is just 3. Okay. Right, now we have the limit as x approaches negative infinity. Again, we can't plug in numbers, so we look at the highest value of x in the denominator, and we're going to divide everything by that. Okay, we're going to reduce all those fractions. And now we're going to take the limit. And again, as the limit even gets a negative number, all of these fractions, right, so you have a very large negative number on the bottom. Again, those are all going to have a limit of 0. And so what we have left is 4/3. And that would be the limit of this function as x approaches negative infinity. Right, let's look at 2 more problems. Right, so the process, highest power of x in the denominator, highest power of x in the denominator. Want to reduce. And now look, I have all of these fractions. What's going to happen as x approaches infinity? They're all going to approach, that's an arrow and a 0. All of those are going to get closer and closer to 0. So what do I have on top? 0 over 5, which is 0. So the limit is 0. Okay? Now, in this next example, the highest power is x squared, so I'm going to divide by all of that. And hopefully, I'm going to do this in my head. I'm going to divide x to the 4th over x squared over x squared, 2 over x squared. So I'm dividing and reducing at the same time. So I want the limit as x approaches negative infinity. So I take all the fractions. All of those are going to go to 0. But look at what I have left. I now have x squared plus 1 over 1. I still have to take the limit as x approaches infinity, negative infinity, and I still have an x. So what's going to happen? I take a really large negative number, I square it, and I add 1. Is that going to approach a particular number? No, it's just going to keep getting bigger and bigger and bigger. And so we would say the limit does not exist. Now the reason I wanted to do those two examples side by side is because here the highest power of x was in the denominator and you got 0. On this one the highest power was x to the 4th was in the numerator and you get does not exist. So when the highest power is on top, you're always going to get a does not exist. When the highest power is on the bottom, you're always going to get 0. But when you have the same on top and bottom, you're going to get a numerical value of x. So keep in mind that this last process was just for infinity. If you're plugging in numbers, just plug in the numbers, see what you get. If you get 0 over 0, you need to factor and reduce and then find the limit.